Okay, third video for ionic compounds. Again, this should be a quick one. The last 3 or 4 examples here. If we look at the last 4 examples, we have iron and chlorine together, copper and bromine together, chromium and bromine together, and tin and oxygen together. And if we look at all those metals, the iron, copper, chromium, and tin, iron, copper, chromium, and tin. These are all metals in the D block and in the P block underneath the stairway here. And they are going to form multiple stable ions. If you look back in your notes, up here, what was it? Many of the D and P block metals are also exceptions to the octet rule. They are called variable charge metals. And if we look at our polyatomic ion sheet, at the bottom we have copper, chromium, iron, and tin. And if you notice, there's 2 different coppers, there's 2 different irons, there's 2 different tins, there's 2 different chromiums. Now we got to figure out which one it is, and then when we name it, we need to put the Roman numerals in. So let's do this here. Many D and P block metals have multiple stable ions, like I said. Use Roman numerals to specify which ion is formed. So manganese. Manganese can either lose 2 or 3 electrons. It can be a 2+ or a 3+. If I write manganese Roman numeral 2, that means it's the 2+ version. If manganese Roman numeral 3 means the 3+ version. Now, how do we figure that out? Here's our polyatomic ion sheet. This first example, we have FeCl3. FeCl3. Now, I want to name that. I know it's iron and I know it's chlorine, so iron chloride is almost the correct full answer, but we need to figure out which iron it is. And the best way to do that is kind of write it out. Write down what you know. Okay. Iron, we know, can either be a 2+ or a 3+. We don't know which. We do know what chlorine is. If we look up here, chlorine is always a -1. So chlorine is a -1, and we have 3 of those. We have 3 chlorines. 3 times -1 is a total of -3. Well, one of the things is we want these to add up to 0. The whole reason we do the switch trick is to get these charges to add up to 0. So if we have a -3 on this side, we need to cancel that out with a +3. So that means this iron must be the +3. So when I name it, I would write iron 3, and it's chlorine, but the second one becomes chloride. So chlorine becomes chloride. So iron 3 chloride would be the name of FeCl3. Let's look at another example. Cu and Br. Copper and bromine. Again, copper, we see here, can be a +1 or a +2. 1+ or 2+. We don't know which. The way we figure it out is by looking at what it's paired up with, bromine. Well, bromine, right here, is a -1. Again, our goal is to have these things add up to 0. Well, if this is a -1, this must be a +1. So it's not that version of copper, it's that version. So copper with the 1 plus is called copper 1. Whatever the charge is, that's what the Roman numeral is. So I would name that copper 1. And again, second one becomes IDE at the end. So bromine becomes bromide. Why don't you try the next two examples here? Chromium and bromine, and tin and oxide. And actually, we'll talk about this here in just a second because that is a typo. Yeah, do chromium and bromine here together. Pause the video, do it, and then when you come back, we can go over it. Okay, CrBr2. Oops, CrBr2. Well, again, chromium, we have the option. Could be a +2 or +3. No, the typo on here too. The plus should be on the other side of the 3 there. So 2 plus or 3 plus, those are our options. Well, if we look at bromine, bromine is a -1. There's 2 of them, so that gives us a total of -2. On this side, well, to cancel out a -2, you'd need a +2. So it must be the +2 version of chromium. So I'd name that chromium 2 bromide. The other example, there was a typo. So I'm trying to figure out what the typo is here. We'll fix that typo, and then we'll name it. So pause the video, fix the typo, and then name it. Okay, SN2O4. Hopefully figured out what's wrong with that. And the problem with that is a 2-to-4 ratio can be reduced. If you have an ionic compound and you have a ratio that can be reduced, you always reduce it. So a 2-to-4 is the same as a 1-to-2 ratio. So really that should have been SNO2. Now let's name that. SN. SN has the option of being a +4 or a +2. Oxygen, we know oxygen is a -2. So on the negative side, I have two oxygens times -2, so that's a total of -4. So if -4 on this side, well, what cancels out a -4? The +4. So it must be tin 4. What am I doing here? Tin 4. Remember the second one always ends in IDE because there's no polyatomic ion here. If there was a polyatomic ion, I'd just take it off here. But oxygen is just oxygen, so it becomes oxide. So hopefully you're getting that. That third video was a little bit longer than just a minute, but this is some kind of tricky stuff, so I want to make sure you got some good examples. If you have any questions, like usual, stop in on days off or before school, anything like that, and I can answer any questions you may have. Thanks.